We're going to turn our attention to two very popular trigonometric integrals. It's not a surprise that they fall back towards trigonometric identities. So the first couple examples here just says to manipulate this equation until you get this identity. Why don't we do that? Recall the most famous Pythagorean trigonometric identity from trigonometry. We can see that the square of sine of theta is equal to 1 minus the square of cosine of theta. We're going to take this equation here and rewrite it. And we're just going to manipulate this, make appropriate substitutions, and keep the next equations balanced. Notice the next equation will indicate the cosine of a double angle is now equal to 2 times the square of cosine of theta minus 1. With a little bit of algebra, you could see that. And with a little bit of more algebra, we can certainly see this, which is the desired equation that we're looking for. I recommend that you do a similar process for this equation here. You could pause the video and try this yourself, and then you could unpause the video and check your answer later. Algebra is such a powerful tool, especially in the study of calculus. Let's go ahead and integrate the following integrals. Notice both of them are indefinite, and all we're going to do is take those new identities from above and make an appropriate substitution. We know that 1/2 is a constant, and with your integral properties, you know what to do with that. Now we see a function living inside another function, and we're going to attempt to make a U-substitution. From there, we'll write differentials. We now see that 1/2 du is equal to d theta. We're ready to anti-differentiate this. And notice because there are multiple trig identities, there are many forms of an answer here. I'm going to pick one. I'm going to pick this particular one here. Notice this method does use a U-substitution for integrals. Feel free to practice this with the next example. You could pause the video, attempt the problem yourself, and then when you're ready to check your answer, feel free to unpause. Once again, you have to do a U-substitution here. You could also check your anti-differentiation with differentiation. Notice in both these examples, all you did was simplify an expression. Here's a quick recap and relearn. Feel free to integrate these again. I do want to mention that this integral here could take on alternative forms. Notice this indefinite integral requires a U-substitution. And because -1 is an integer, we could apply logarithmic rules and absolute value rules to see how this integral may take on different forms. And you could check these indefinite integrals with the derivative of your family of antiderivatives to get the continuous function that you started with.